Okay, let's get started. Welcome back, everyone. Hope you had a nice lunch, nice coffee. Get back in your comfortable chair, sleep. This talk, I don't know if this talk is going to be informative or entertaining. I can tell you at a minimum it's not going to be as depressing as my morning talk. So don't worry about that. You can watch me fail. So how many of you know Kotlin? Are using it? Okay. So this is Kotlin 102 Beyond the Basics. If you don't know what 102 stands for, is my play on 101. So it's a little bit beyond the hello world and basic stuff. It is not a deep dive. It is not a very deep dive, I should say. If it were a deep dive, I would have called this talk Kotlin Deep Dive. It's not. I'm just setting expectations, okay? So I'm going to show you a bunch of different things in no particular order. I'm trying to make an order that actually makes sense for people. And hopefully it will make sense for you. So how many of you have actually been using Kotlin for more than a year? Okay. And who's using it for Android development? Outside of Android. There is a world outside of Android, and it's beautiful. It's wonderful. Right. Okay. So hopefully at the very top you can see that it's good. Font size is great. Yes, excellent. Right, so just so that we're all on the same page, you're all familiar with the syntax of Kotlin. So I have higher order function, for example, and I have an int and returns an int. Okay, that's a higher order function in Kotlin. Hopefully you're all familiar with that. You know how to write it, how to read it, all of these things, so I don't have to deal with that, and we're all on the same page. Okay, so Kotlin, as you know, comes with a whole bunch of functionality when it comes to functions. So for instance, I can have a list of numbers and have a range of numbers and then say, for example, numbers, filter, right? And then filter, say, for instance, those that are less than 5, and then concatenate that, pipeline that, or however you want to call it, with another function that will map it. And then with that one, do, for instance, a for each. And that's going to do like a print line it, etc., etc. All of these are functions that are part of the standard library, and you can navigate to them, and you can see that they're extension functions on collections. So that's wonderful, fine, and dandy. What happens when I want to go a little bit further than that? What happens if I want to kind of move towards more functional programming? Well, it kind of depends what you understand by functional programming, because some would call this functional programming, right? Functional programming at the end of the day is essentially functions used as primitive building blocks. So if I have a higher order function and I can pass in one function to another function and do a whole bunch of things with that, then you, by all accounts, you can basically say that that's functional language, and it's a functional constructs and functional programming. Then there are those that say, no, functional programming is only Haskell. Or if you're .NET, functional programming is only C#. Sorry, C#. What am I saying? F#. F#. You know, that language that even Microsoft doesn't care about. So it very much depends, right? I honestly don't care. You can call functional programming anything you want, but there's different things that you can do. Now, Kotlin comes with a standard library. A lot of times people say to me, like, why doesn't Kotlin come with X or Y or Z or whatever? Because Scala comes with that, and Scala comes with this, or Haskell comes with that. Well, then, because Kotlin is not Scala and Kotlin is not Haskell, and there was never an intention to make Kotlin anything like Haskell or whatever. But we've always created Kotlin in a way that you can essentially extend it, and you can create higher order functions to extend it and make it look like a part of the syntax, etc. And a lot of that is in the standard library, and then there's a whole bunch of things that could be provided outside of the standard library. And in the Kotlin ecosystem, there was namely 2 libraries which were great for functional programming. One of them was called Functional with a K. Anybody used Functional? No? It was written like this. It was written functional. Functional. Okay? It was very original, the whole K thing, until it got extremely annoying. And there was another one which was called category, and yes, you guessed it, with a K. Okay? Category as in category theory, because that's what developers like to learn about, category theory. So these two joined forces and they created another one called arrow. There's no K in it. Yes, there is. There's a K, which comes with an extremely CPU-intensive website. And well, it's true. And then they say that functional programming doesn't really have a performance impact. Well, the website does. So this is actually a library developed by a few people in collaboration. Anybody ever used this? Right, one person. So the good thing about this library is that they've made it very modular, so you can bring in anything you want. And it provides a whole bunch of constructs in addition to what the standard library provides. And there's many things in there that you could actually just basically replicate yourself. It's 2 or 3 lines of code, okay? And I'll just show you some of the quick ones here, and you can delve into more of it if you like. So let me just expand on this one over here. If only I knew how to navigate an IDE. Okay. So if you're familiar with functional programming, a lot of times what you do is you basically have a function that returns a type, right? It returns a type T. And then let's say that you want to do something like some error control. So you can say, for instance, I want to create a function that says get page, and then that page has, for instance, a URL of type string, and then we say, if URL is not empty, then return something else. We do very good error handling, which is throw top level exception. Bad, right? So this is, you generally don't do this type of error handling, do you? And those that do remain quiet. So what you normally do is maybe do something like a result, right? You can return a result, and then you can have a class result, and then you can have a class failure that would inherit from result, and then you would have a class success that would inherit from result. And that's fine. You have your 2 data classes, and now you could say, well, if it's success, I would return a success, and then this could, for example, be a message that we would have, for instance, here, or the content. So I could do, for example, val content of type string. So now I would return success, and in the case of failure, for example, I could throw an exception. Okay, so in this case, I would do something like return exception. So here I would say return failure, and then bad would be the message, and then, or it could be, for example, the type of the exception or what have you. Now this is all great. The only problem is that, as you know, in Kotlin, this is classes are closed by default, so I have to declare it open. If I declare it open, there is nothing preventing someone else to go some other file or in this file and create a new class that inherits from result. And we may not want that, right? We want to close the hierarchy. And this is in functional programming often called as a algebraic data type, right? We just want to basically limit the type to one or another type, or however number of types. So in Kotlin, instead of using open, what you could do is use sealed, and then essentially what that will do is close the hierarchy so that now you can't actually have another type inheriting from that in a different file. It will only be able to inherit in the scope of this file, which means that at least you have awareness that it's going to only do it there. Now, when you use this, of course, this is all nice because I can say, for example, result equals, and then do get page, and then some URL. And then what do I do with result? Now I've got to do when result, and then, is success, then do something. When it's failure, do something else. And you start to see a pattern develop, which is like, okay, this is cool. I can use an algebraic data type to give me more insight into exactly what's happening. But now, every time I have to add a whole bunch of boilerplate code to check whether it's one thing or the other thing. Yeah? So it gives you clarity, but it also adds a lot of boilerplate code which may not be necessary. And that's where some of the things that are available with Arrow can be often useful. So one of these is, for example, the either class. Okay? So either essentially is a generic implementation of what I just showed you. Instead of having a result that returns a success and a failure, you can have just a type that returns either one type or another type. And you could say, well, I could implement that myself. Absolutely, you could. You could actually basically create a result of T or a result of T and K and then basically do whatever you want. The difference with what this provides you with either is that it also gives you it's a type that gives you additional functionality, right? So here you can see that, for example, I have a get VAT value and I say that this function either returns non-applicable or returns double. And then I say if the country is different to Spain, then return left, which means this one, else return right, which means this one over here. Now, when I use this, instead of doing a when return type is left, because you actually could, like if I come to result here, if we do val b equals get VAT value of something, you can see that has an is left, right? So I could now do this check in my when statement and say, well, if it's left, do this. If it's right, do the other thing. But what this introduces is a higher order function, which is called fold, which basically takes two functions, left and right. Okay? So what it's doing is allowing you to still use these algebraic data types where you return one type or another, but it combines that with higher order functions, which allow you to then say, well, if it's one type, do something. If it's another type, do another thing. Removing all of that boilerplate code. And then you can start to chain these things, okay? So I have either. Then you have a specialization of either, which is, for example, valid, which is in the case of a computation. You can say a computation returns a valid result or a computation returns an error. It's a specialization of that either. Then you can have, for example, the try. And the try basically allows you to wrap the exception in a data type as well. So instead of your application actually throwing an exception, it can just return an exception and then you can query on it. Okay? This is essentially, if you think about it, it's more kind of like a generalization also of the concept of the question mark, the safe operator in Kotlin, right? Which leads us to option. If you're familiar with the safe operator in Kotlin, it's like if it's not null, do something. Yes, we do say question mark dot invoke, and Kotlin will only invoke that if it's not null. That is basically an implementation at language level of option. An option is the concept of a type that returns something or nothing. Okay, so arrow also provides you with option, but much like you see with the either, validated, etc., it allows you to do other things with options. So it allows you to actually chain methods. Right, so you can now have options that you're chaining results and then calling one function over another. So if you're into a little bit more functional programming, you may want to check out some of the things that Arrow provides you, and you'll see that a lot of these things are actually very simple in terms of implementation. So one thing that, for instance, you do a lot when it comes to functional programming is composition, right? So let's say that I have a lambda function here. You can see that I have a lambda function that's source, and I have another lambda function which is all lines, and I have a find matches which takes a bunch of strings and then returns those that match a single regular expression. So if I say, well, let's find all of the values, all of the files, for example, that have the word controller in it, how could I do that? I could basically create a function that takes the source, gets the result, pipes it into another function, gets the result, puts it into another function, or, which is what you can see here, or what I can do is essentially just use this concept of composition, which is saying that take the find matches, compose that with the all lines, compose that with the source. Now, what is compose? Compose is essentially an infix function in Kotlin, right? But it's an infix higher order function. So it takes two functions and then it composes them. What is the implementation of compose? In Haskell, this would be find matches dot all lines dot source, right? We don't have the dot operator in Kotlin. So what is the implementation of compose? Well, if you navigate to it, compose is essentially just a very simple inline infix function, which takes one function and calls it with the parameters of the other one. And all of the many of the other things that are provided, like, for example, partial function applications. The concept of partially applying a function is that I can take a function that has, for example, two parameters, set the first parameter, and then obtain a new function with that first parameter set. So for instance, if I have a function sum, which you can see that is an x plus y, if I do sum partially 1, what that's going to do is return a new function for me with the first parameter set to 1. So now if I were to do sum partial 3, it would give me a 4 because the first parameter is already set. But it's giving me back a function. And what is the implementation of partially 1? Well, let's look at it. It's very simple, right? It's basically calling a function with the parameters being passed in. Now, arrow comes with partial function applications for 22 parameters. And if your function has more than 22 parameters, your issue isn't that there isn't a version of partial available for it. Okay? So if you are curious about functional programming a little bit more, if you have kind of come to Kotlin from maybe Scala and missing some things, I recommend you check out Arrow. And the good thing about it is, like, if you just want to use either or try or validated, all of these, you can just basically pull in these data types without having to bring down the entire library. Okay, so now we saw just recently here that I was doing, for example, let's delete all this. So I had the numbers 1 to 100, and then I had numbers filter those that are, for example, less than 5, map this to something. Okay, now this is essentially all collections in Kotlin, right? And we don't have, well, I say we don't have, I'll put into quotes because we actually do have something now, but we don't have our own collections in Kotlin. What we do is we provide interfaces on top of the Java collections. Okay, so we provide the mutable or the immutable. By default, everything is immutable. So if you want, for example, a list that's immutable, you do list of. If you want a mutable list, you would have to do mutable list of. But all of these are operating on collections, and they're doing it in an eager way. So essentially, when I take filter and I say I've got 100 numbers, and then I do a filter, it's going to create a collection for me of those that match that criteria, that predicate, and then on that, it's going to map and create another collection, and so on and so forth. Oftentimes, when we have infinite amount of data, or we have very large collections, and we want to avoid creating so many duplicates, so many copies of data, just because we're doing some processes, how do we do that? In Kotlin, you're familiar with sequences, right? Yeah, sequences is similar to streams in Java. So essentially what you can do is you can take any collection and do as sequence, and as soon as you do that, it's basically converting this into a stream, which would be kind of like the equivalent in Java. So now it's doing lazy evaluation. Now the process is completely different. Now it's essentially taking each function and applying it to just that element and then passing that to the next function and so on and so forth. Now sequences in Kotlin are composed of two types of operations. They either have intermediate operations or terminal operations. All of these, in this case, are intermediate operations, meaning that this isn't actually really going to do anything. It's only going to do something, have an effect, when I add a terminal operation to it. So a terminal operation, for example, would be take 5. As soon as I do take 5, now it will actually start to act. So if I had a million lines here, a million elements, it wouldn't have to process all of those million elements. It would just process those until it reaches that point that it doesn't need anymore, which in this case would be 5. So you can basically take any collection and just convert it into a sequence by just doing as sequence. In the case where you do not have a collection to begin with, you can use the generate sequence higher order function. Right? So the generate sequence essentially takes a seed. So I can say, for example, here, and then I would say return that seed times 10. And then now I could do, again, a map times 4, and then do for each, and then print line it, and then, sorry, I could do, for example, take 5. Right? So this would basically generate an infinite sequence if I wouldn't put this take in here. And then in this case, it's just going to generate a sequence until I reach 5 and print out the results for that. So sequences versus collections, when do you use one or the other? Collections, remember, they're going to make a copy of anything that you do. So if you're having a lot of data that you're trying to process, if you're having infinite amount of data, generally you would recommend to use the streams. Okay? Next, let's take a look at built-in delegates, which you're probably all familiar with, right? You've all used lazy, observable. Yes? No? You're sleeping? You're still pissed off at me because of the talk? So lazy is essentially what we're all feeling right now in these nice little chairs. We have property delegation in Kotlin. We have class delegation and property delegation. Class delegation I won't get into because really, personally, I don't like it. I don't use it. And I don't know. I just, yeah, whatever. Then we have property delegation, which is very, very useful. So what this is saying, if you're not familiar with the syntax, is that I have a lazy property which is going to be delegated. The functionality is going to be delegated to some other function. In this case, it's delegated to the internal built-in function in the standard library, which is called lazy. And if we navigate to lazy, we can see that it's a function that's built in to the standard library. Right? And what this does is basically do a lazy evaluation of the property, meaning that the first time I access it is when it's going to invoke it, and then it can cache the results. This is already built in, and you use this quite a bit. You know, you don't have to repeat this code over and over again to just have some lazy evaluation of a property. But there's some other ones that are built in that people often don't know about, such as, for example, vtobal. Vtobal is fantastic. It essentially allows you to set a property if it matches a certain condition. So here in this case, I'm saying that the string is delegated to delegates.vtobal, which is again a function inside the standard library. And I'm saying that if the new value set starts with an S, then it will set the value. If it does not, then it will not set the value. Right? And again, this is logic that I don't have to repeat over and over again because it's part of the standard library. So in this case, you can see that I can create a class veto, and if I run this, I say set the value to, it starts with a value of, what does it start with a value of? String, and then it says change it to change. It prints it out again, it hasn't changed it, and then it says change it to strange. In this case, it does change it because the value set starts with the letter S. Okay. So this is, again, I would recommend that you look at some of the built-in delegated properties that are available in the standard library. There's one also about observable properties, which is a quite common pattern that you wouldn't need to implement yourself. If the case would come that you do not actually have something implemented, you can create your own custom delegated properties. So in this case, all you need to do is essentially create a class that overrides two operators. One of them is called getValue, the other one is called setValue. Okay? And then this has a certain syntax, which is basically the class and then the property. This is a K property. Anyone familiar with what a K property is? It's a property, but Kotlin's. That's why it's called a K property. Very original. So this gives you some information because, as you know, Kotlin has its own reflection, so it provides you some information on top of what the Java reflection provides you. And then you could basically create your own custom delegates, and then you can use them in your properties much the same way. Okay? This is the way to essentially kind of like if you're familiar with Ruby, you have the mix-ins, the concept of the mix-ins a little bit. It would essentially be the same thing. Okay. Next, what can we see? Right, type aliases. Type aliases. How many of you use type aliases? Okay, type aliases are kind of cool. So let's say that I have a customer here, and then I'm going to, well, let me rephrase first what a type alias is. Here's a type alias. Email equals string, right? So that means that anywhere that I have email, it's exactly the same as string. So at runtime, there is no type email. It's just a synonym to string. Wherever I can pass in a string, I can pass in an email. Wherever I can pass in an email, I can pass in a string. What is the use of type aliases? A lot of people use it for creating higher order function syntaxes. So instead of, for example, you know, passing in, go away. I'm going to need internet later, so my apologies. Thank you. No, I won't go to your Facebook account. Right. So I could say, for example, my bifunctor is a function that takes an int and another int and returns an int. And why would I want to do that? I don't know. Some people do. I like my higher order functions to be more explicit so that I actually see the parameters. I don't want to look for type alias. But surprisingly, a lot of people do that. One use that type aliases come in are for moving towards deprecation of your API. So let's say that you have, for example, a class customer, right? And now, or we have a class even more meaningful, service, right? So now I have an instance of service, and I've done service over here, and I've shipped this API, and I now want to change this because somebody came and told me that what I need to do is microservice, okay? Well, not microservice, now it's serverless. And apparently people get very annoyed when you say that serverless is the new CGI bin. So what I would do is I could rename this. Of course, if I do, I'm going to break everyone that's consuming my API. So I could introduce a type alias that says microservice equals service, right? And now in my code base, I could start to use microservice and leave the service class there. And what I could also do is add a deprecated to service and say, deprecated says message, this is now a microservice. Yay. With Kubernetes. Why not? Because everything needs Kubernetes. And then you could do just replace with, and then here I could do microservice, right? As soon as I do that, you see what happens in the IDE. It strikes it out, and it says this is deprecated, right? So you can see that it gives service is deprecated, and I can now replace it with a microservice. So it allows me to do like a two-phased deprecation. First, I add the deprecated. I allow people to start to get this hint, do the quick fix, and then eventually I will remove the type alias and I will do the renaming of the class. Very useful for when you want to break your customers' APIs and not charge them. If you want to charge them, then just don't introduce the type alias. Okay. So, experimental. Experimental is this thing that we've added to Kotlin because we do a lot of experimental things. And we want to, tell you very explicitly that what we're doing is experimental so that you don't later say, you broke my code. We've actually been kind of good in that pretty much everything that we do that's experimental, and if it radically changes, we try and introduce quick fixes also in the IDE, allowing you to upgrade easily and do a nice quick search and replace in a better way than just search and replace. But the idea behind experimental is essentially that you can also use it for your stuff. So here you can have, for instance, experimental annotation class, which is called new experimental API. And then I've got this microservice API, which I decorate with the new experimental API. So what happens now? If I were to remove this, you can see that if I start to use microservice API, it's going to give me an error. And it's going to say that this is experimental. So it's allowing me to introduce experimental things in my API, in my classes, in my jars, whatever I ship. So here I could say, well, I want to use experimental, and then I would say add annotation, new experimental. Okay? So now I'm explicitly saying and warning that this API is experimental and would be subject to change. It's kind of like a CYA, if you will, right? And if you don't know what that means, the acronym, you can look that up. Or CYB, cover your back. Now there's another one that you can add is also use experimental. What is the difference? Well, in this case, there isn't really that much difference, but notice what's happened. If I use microservice API as new experimental, anywhere I use it, I have to decorate that function also with experimental. If I were to use the other signature, which basically propagates, then I don't have to be explicit in all of the usages. So I can just say that this is experimental, and then wherever I use it, it's fine. So one of them is propagating, the other one isn't. In order to use this, if you ever want to use it, the first thing that it will give you is an error saying in order to use experimental, you have to add the experimental flag to the compiler, which essentially means that you have to come here to, if you're using Gradle, or Maven, you've got the same parameters, or command line, and just say use experimental kotlin.experimental. And then that removes the warning and it allows you to work successfully. And this concept of experimental is something that we'll see being used in some of the things that we'll move into shortly. But let's go back to some higher order functions over here. And I want to look at inlining. Okay? So, first of all, if you see, for example, where was I? Functions. So we saw that I had, for example, val numbers 1 to 100, and then numbers filter, right? Filter is inline. Does everybody know what inline is? It's a famous way, it's a very nice way of saying copy-paste. So essentially what will happen is that when you inline a function, it is going to inline the function into the call. So it's going to copy-paste the code inside the call site, right? It's not going to, there's not going to be a call on the stack. So what happens here? Well, let's see. If I take a function and say ABC, and then I have a parameter, for example, a value of type string, let's say, and I say inline, you see that the compiler complains, right? It says, oh, you don't need to inline this because the impact on the performance is not going to be noticeable because the JVM does a great job of inlining, and you don't need to worry about that. So when do you inline? When you inline, usually is when you have higher order functions, because it also inlines the lambda. So in this case, if I add a higher order function that, for example, takes no parameters and returns a unit, then the inline warning goes, because it makes sense for the function now, right? Because now I'm not only inlining the call to that function, but also the contents of that lambda. Now, knowing this, let's take a look at some code. So here I have some code that is a function called containing function, and it's going to call it. And it's going from numbers 1 to 100, it's going to go loop through them, and those that are divisible by 5, it's going to return and then print hello. If I were to run this application, what do you think the output would be? Hello? Yeah, that's what I'm saying. Is there anybody out there? Hello. Who thinks it's hello? Some people are like trying to raise their hands, looking around saying, is anyone else? Okay, who thinks it's not hello? Okay, well, great. It's not hello. Why? Because of what? The return here. No return type of the function. No. There's a return there. So where's that return going? It breaks. Why does it break? Aha, there you go, right? There you go, because the Kotlin documentation tells you that, right? Yes, exactly. So, well done. Let's move on to something else. No, I'm joking. The reason for that, obviously, is because of for each, right? Because for each is what? If you take a look at for each, it's an inline function. So when this code is actually put in place, it's copying and pasting the for each into that place. So the return is acting on the containing function. And that's what's called a non-local return. And by default in Kotlin, everything is non-local. So when I return, because the for each is inline, it's actually returning from the only function that is there, which is containing function, and therefore print hello is never printed, right? Then you wouldn't be able to even do that. Is that you, Václav? No, no, sorry. You just sounded familiar to a guy I know. Yes, so if the function is not in line exactly, you wouldn't be able to do that, right? Why? Because I'll show you in a second. Hold on. There's other ways to do it. Hold on. Calm down. Okay? So, now, how do you do that? Well, you've got to indicate this in a different way to Kotlin. So how would I say, whether the function is inline or not, how would I say that I want to return to do a local return? So here, you can see that I actually have, going back to the example that they just said, my for each. This my for each is exactly the same as the default implementation of for each. And if I were to remove this inline, right, and then replace this for each with my for each, you see that it says return. Your return is not allowed here because this is not an inline function. So that's where we go to local returns versus non-local returns. So if I want to go to a local return, what I can do is actually do a return at for each. So I put the at and referencing the function that I want to return at. So in this case, I want to return at for each, in which in this containing function 3, it would actually print out number 3. Then I could also do explicitly my label and return at my label if I don't want to use the name of the function. Okay? Now in Kotlin, in any language, if you say anonymous function, it's synonym to a lambda. In Kotlin, we're actually a little bit different. We have lambdas, but we also have anonymous functions. This is an anonymous function. In this case, the function is defined with no name, as you can see. And the reason that I bring this up is that because with anonymous functions, it behaves differently than the lambda. It will return to where it was, right? So it will do a local return. So if you want to do a local return, you would either use the anonymous function or you would use the labels. Now, inlining, we just talked about how this brings you certain benefits in terms of performance, especially when you're using lambdas. But there are times where you may not want to have something inlined for whatever reason. So that's where, for instance, let's say that I have a higher order function and I have one that returns unit and another one, G, that returns an integer and returns a unit, right? I can inline this because it's a higher order function taking two functions, so everything is wonderful, everything is great, so there's no problems. Now, the problem with this is that if I come and say val x equals g, right, notice what happens. It says illegal use of inline function. Why? Because I can't hold a copy of g because there is no g. There is no anonymous object, nothing created. It's just copy and pasted that code. So the only thing that I can do with an inline function, the parameter, is essentially call it. I could just do g here, right? G30. What happens if I want to actually hold a reference to that? That's where you get the no inline that you see sometimes appear in the standard library. So the no inline now allows me to not inline one of the parameters of this higher order function. And then there's another one which you may come across on, which is called cross inline. Okay? So the cross inline is related to what we just saw of the non-local returns. So a cross inline indicates that a non-local return is not allowed. Yeah, because in this case, you wouldn't be able to hold the reference. Okay? So, those are some things. You're going to see this a lot in the standard libraries and other libraries so that you know what they're referencing. Now, all of this in terms of inlining is great for performance. Is there any other reason I would ever use inlining? Yes, when it comes to reification. If I remove this, you can see, sorry, not inline. If I remove reified over here, you can see that is if input is t, I no longer can check because JVM has type erasure, so I don't know what that list of any was, whether it was a string or whatever. We provide certain level of reification in Kotlin by basically allowing you to reify certain inline functions. So here, if a function is inline, I can do reified for the type parameter, and then I could do certain types of introspection on the type. Not all. I can't, for example, create an instance like you can do in C#, which is fantastic, but I can do certain kinds of checks. And in the latest version of Kotlin, we've even introduced a standard function in the library which is called typeOf, which essentially is giving you the type of the actual T being passed in. So this is essentially a reified function that gives you the K type, which would be the same as I'm printing out here. Okay, so inlining is great for performance. You can also use it in cases where you want some level of reification. Now, this is all about inlining of functions. But we also introduced another thing in Kotlin, which is inlining of classes, and this is experimental. And you can see that I have this experimental annotation over here. So this is an experimental feature, and the idea of it is basically an inline class. So different to type alias, an inline class is actually a different type. It does represent a different type, meaning that if I have, for example, here an inline class name, I can't pass in a string where it's a name. I have to pass in a type name. Now the name, an inline class always has a single property which has to be passed into the constructor, and in this case it's value string, and this is how the underlying class is going to be represented in bytecode. So this is doing the performance improvement of taking a type and not having to deal with the boxing and unboxing and dealing with it as a primitive value at runtime. But during your coding, it will give you all of the benefits of having a strongly typed type, which is specific to what you're trying to represent, different to type aliases. Okay, and I'll show you an example of how this can be useful. So here you can see that the inline classes have certain restrictions. As I said, it has to have a constructor with a single property. And all of this essentially gets translated into bytecode, and this is greet becomes basically a static method, name length becomes a static method, okay? And this it becomes a static method of type string in this case. So this now gives us way to do some other interesting things because we get rid of some of the performance impacts and the hits that you could have by just having, for instance, a primitive type represented as an actual type. So let's see what we can do also with experimental. Contracts. Now, if you're familiar with C#, how many of you here have ever seen C#? Okay. Remember that thing that Microsoft introduced and essentially killed? It was called code contracts many years ago. They came up with this great thing called code contracts, and then they just killed it. So we've got a similar thing here in terms of contract, which essentially is experimental at this point, but it's basically putting in some guards for your code. It's preconditions that your function has to meet. So why is this interesting? Because in this case, what I'm saying is I'm creating a new function called not null. Now, if I were to remove this, and there's a bug because this should give an error, but trust me, there's a bug. So I'm going to build it so that you can see that this won't compile, hopefully. Yeah, you see it doesn't compile because it says the safe operator, the safe operator needs to be used here. Why does it need to be used here? Because the compiler doesn't know that this is going to check that this is not null, and therefore it's checking to make sure that the value is not null, right? Because it's acting on a nullable type string. Now, what the contract does is when I put this contract in place, again, there's a bug here because it should get rid of the squiggly or put the squiggly. Now, it's basically saying, I'm going to guarantee that the string is not going to be null on entry of this function. So if I compile this, you see that the error now goes away, okay? And it compiles fine. So what this contract is saying, the contract is essentially a higher order function, which now it doesn't want to go to. But what it says, it returns true if it matches a certain predicate. Okay? So this is a way of you doing your checks or guards. I think that Swift has the concept of guards as well, just like Haskell has some of these things. So this is a little bit the direction we're moving in. It's experimental. It's still quite limited in what you can do. Combining this with DSLs and some other features that we could add, it does open up many doors. We've also added a few APIs where we're using the whole concept of experimentals, etc. And the inline classes. So for instance, here what we've added is this. Actually, this is a new API call that we've added, which is trim margin, and trim margin does the optimization at compile time. So it can actually check that and replace it with this line over here without having to have a penalty impact at runtime. So we've added some new functions that do compile time optimization. The inline classes that I talked about is very useful for this duration class that we've added. So duration, a lot of time, if you've dealt with time, you've had to like look at the function signature to say whether it's get duration in milliseconds or whether it's the parameter says milliseconds or whatever. And we've added a new class duration. And the great thing about duration is that it now is more explicit, right? How long is the duration? What are the units, etc. But because it's an inline class, there really isn't any penalty impact, right? So it's giving us that explicitness, that conciseness, not conciseness, the explicitness of how the expressiveness of the code without the potential performance impact that it may have by just introducing a new type. Okay. One other thing that we're introducing, which is experimental as well, and this is part of no longer part of the standard library, is immutable collections. Right. So as I said initially, we've always been of the, we don't have our own collections. We have immutable interfaces or mutable interfaces on existing Java collection. There is now a project which is called Kotlin X Collections, which allows you to easily convert mutable to immutable and a bunch of other API calls that are being introduced. But that is a third party. It's a first party library, which is ours, but it's not part of the standard library. If you're interested in that, now would be a great time to start looking at it and provide any feedback. Okay, to finish off with a few minutes that we have left, I just want to touch on DSLs, which is kind of nice. So one of the things that we've always strived to do with Kotlin is make it a language that's very easy for you to create DSLs, right? Who's familiar here with DSLs? Okay, DSLs are domain-specific languages, which means that they're languages that are specific to a particular domain. And that's how I explain things. I just turn the words around. So I'm going to do some DDD, which stands for no, DSL-driven design. So I'm going to do some DDD. So let's say, for example, I'm using I don't know, a cloud provider. So I can say, for example, cloud. And then in that cloud, I can say, for instance, provider equals AWS. And then I can say instances. I have no idea what I'm talking about here. CPU equals big. And memory equals even bigger. Or Slack permissible, which means you can run Slack. So let's stay here, okay? Now let's assume that this is a DSL that I want to create, right? How would I go about doing that? Well, you turn off error notification and you're done. I'm driving out what I want to do from my actual end result. So what I could do is do Alt-Enter programming. So I say create function cloud any. Right? Now, this is great. I've now got my function cloud, because if you look at this, this is essentially a function, right? This is a function, a lambda, a multi-line lambda. So how can I play with this a little bit? Well, what am I providing here? I'm providing a provider, instances. So I could say, for example, I could have a type which is called cloud, right? So now I could create a class cloud, and then this class cloud, for example, has var provider of type string, and then var instances of type instance. Let's just make it one instance, for example, for now, to make it simpler. Instance, and then I'll have a class instance, which has, for example, var CPU of type string, and then var memory of type string. Okay, there you go. So now I can kind of do this, but I'm going to even initialize this with emptiness. And you don't do it this way in the longer run, but we'll just cope with this for now. No, that should be instance. Okay, we're done. Yes, that should be instance. Okay, so I've got my cloud. Now, what is this saying to me? It's saying, okay, well, this is not right because there is no cloud here, right? The problem is that how do I represent this property? Well, you know that in Kotlin, if the only parameter to a function is the first is 1, you can just write it. Right? So I could get it provider, so on and so forth, right? Okay? So this is actually, sorry, this should be a function. Okay, so if I do it provider, now I can start to treat this as if it were a function. But this it looks horrible. It just doesn't fit nicely. Now, what is a higher order function? A function that takes another function. What is an extension function? A function. What is a higher order function that takes an extension function? In Kotlin, it's called a lambda with receiver. How do you represent that? You take your cloud and you take it out of the brackets, you put a dot, and then you've got your higher order function that takes an extension function, which is called a lambda with receiver. So basically, this is an extension function to cloud, meaning it has access to the properties of cloud. I do the exact same thing here. The problem is, here I can't do it because this is an object, right? So how can I do that? I hit Alt-Enter. Why? Because you can invoke an instance of an object as if it were a function. So I say create member function instance invoke, and then here, again, I say follow the same pattern, and I say, well, what is this? This is an instance extension function that returns unit, right? And then memory, and voila, I have my DSL. Okay? So it's combining the fact that you have last functions to a function is you can drop the parameters, you can put it as multi-line, the fact that you can invoke functions in Kotlin, and the fact that you can have higher order functions, and in particular lambdas with receivers, give you the ability to create these DSLs, which come in very useful, not only for cloud providers, but also to dictate your business rules, your VAT rules, what have you. Okay, so with that, that's kind of like an overview of some of the more things that you can do with Kotlin. Hope you've learned something. You can ping me afterwards for any questions. You can also reach me on Twitter with Hariri and or Hadi at jetbrains.com. Thank you.